Good morning. This is Mr. Quinones making you a short tutorial video on exploring quadratics. First, so just watch this for a little bit, then you guys can play and explore this. Let's go to our bit.ly website, our IMT website. Go to teacher Quinones. So I added this new link right here. This is exploring quadratics. So I created, I think it's kind of a cool little exploration tool. So I made this last night. I want to show the quadratic here. I'll fix that. Okay. So this is a quadratic with A, B, and C. So let's do a basic quadratic with A is 1. Just A to be 1. I made it to go by really small numbers. We'll put 0. Right there. And let's say B is also, let's say B is 0. And we'll say C is also 0. Okay, so here is the quadratic right here. I'll close this off. Okay, so this is a y equals x squared. So A is 1. There's a 1 for the x squared. B, there's no B. That would be bx. And then C is nothing. So I also added a thing called vertex, x-intercept, and a y-intercept. So right now, the absolute minimum of this parabola is 0, 0 right here. So let's increase this or decrease it. And you see how the as it gets smaller and smaller, and that's 25.25, the parabola gets wider and wider. See 0.05 x squared. And if you get to 0, it's a straight line, there's no more x squared. And then when it gets negative, it becomes upside down. Alright, so there's that, the A. So I want you to kind of toy with this and move it around. So here's B. See, look, B looks like, if I move B to negative, and here's B here, so that'd be your equation. If you move it negative, it actually goes to the right and down a little bit. Kind of interesting how it goes up and down. And if you look at how it's going up and down, it looks like it's going up and down on another parabola underneath, like an imaginary one right here. I'm really curious to know why that. Okay. So as you see, this a dashed line right here. It's not really part of the graph, so I made it dashed in light blue, and that's called a symmetry line. Okay, so I can take it off. So this is the line of symmetry. So it means that this side of the parabola is equal to this side, if you know a line of symmetry. The lowest point of this parabola is called a vertex. And if the parabola is negative, it's also called a vertex, but it's called the absolute maximum. So the absolute maximum, also the name of the vertex. But if the parabola is positive, it would be called the absolute minimum. Okay. I'm going to make this graph go down a little bit like this. And the points on the graph where y is 0 are called the x-intercepts, or where does the graph hit the x-axis. As you can see, there's one intercept here and another intercept there. Let me move this a little more. Get this. There we go. There we go, right here. So as you can see here, there is a y-intercept too, the blue one. The y-intercept is where when x is 0, and the y-intercept is always going to be c. See that? It's number 2. Kind of hard to see here. I gotta zoom in. So look at this. So no matter what C is, or no matter what A and B are, the y-intercept is always C, because x would be 0 on this axis. Okay, on this axis, x is 0, which would eliminate this and that. So all would be left over C. If there is no C, then the x-intercept, the y-intercept is 0. Okay. So now, this is what I want you to do, is kind of explore and make some index cards of what the shapes are and how they're manipulated. Like if you write an index card, if A, and A would be the number in front of x squared. Say if A gets bigger and bigger, the parabola gets narrower and narrower, or skinnier or skinnier, or steeper and steeper. Okay. Think of this as if it was like a bar. Let me put it at 0. Okay. Put this. Okay. So think of this as steel bar, and A is the strength that you use to bend the bar. So as you increase the strength, look how quickly it became a parabola just by adding a little bit of strength. And as you increase the strength, right, imagine your arms are here and here. You're bending and bending. As this number gets bigger, you can bend it tighter and tighter. That's one way to think about it. I think it's pretty cool to think about it that way. And then if you bend it negative, then you're bending it backwards. And if there is no bend, it's a straight line. There is no x squared. Think of B as kind of the opposite way. So if you move B this way to the right, for some reason, which we'll explore in depth later, the parabola goes this way and down. It's interesting. Okay, see that? It doesn't just go to the left; it goes left and down. Kind of sliding, like on some kind of slide. Okay. And if you go to the negative, if B is negative, then the graph is actually on the right side. You can zoom out. Alright, and lastly, C just moves the graph up and down. This doesn't actually make a side, it just goes straight up and down. And it doesn't change the shape of the parabola at all. Okay, so there's no change in shape. B doesn't look like it changes the shape. The same shape. Okay. So B is your strength, B is left to right, and C is up and down. The vertex is the lowest point. Let me move this to a little bit. Okay, the vertex is the lowest point of a positive quadratic. You can find the axis of symmetry. I'm going to hide everything here. Let me put B a nice even number, and we'll make it a nice even number. Make it 4. Okay, so C doesn't really matter for the axis of symmetry. See that? The axis of symmetry would not matter. C just moves it up and down, but the middle is still the same. So you can find the middle of this graph in 2 ways. One of them is you get the opposite of B divided by double of A. Okay, let's make A 1, so you can see. So the opposite of B would make it -2 divided by double of this, which is 1. Double of that is 2. So negative 2 divided by negative 2 is negative 1. Okay, so let's see if that is true. Right here, x is negative 1. You can see that it's indeed negative 1, even though it says right here. Or let's test that another way. Okay, let's make this 4, and we'll make this, we'll leave it at 2. So the opposite of this is negative 2, and divided by double of this. So that would be negative 2 over 8. So negative 2 over 8, 2 eighths. So if you want to think of 2 eighths as, see if I can write on here. Oh, I can't write. Oh, sort of. Okay. And then you can, cut both of those in half. So the middle, the axis of symmetry is negative 1/4. And look at that, x is negative 1/4. Right there. Okay, it works for every parabola that's in standard form. Standard form is when you have y equals, you got the x squared first, and we're only looking at the coefficients. Once you get your middle, well, the vertex is always in the middle. Okay. Once you get your vertex, you're going to plug this in, negative 1/4, into here and here, and then do some calculations, and that'll give you the y when x is there. Okay. So if you don't know the vertex, okay, your first task is to let me see if I can. There we go. Look at this. So, kind of exploring this, if you just kind of give an idea. Think about it like this. Whoops, what did I do? Press undo. Okay. So think of it this way. When you see a parabola, I'm just drawing some random parabola, but I'm not drawing it. So here's the equation. This is the strength, so I know it's going to be like this, but it's a lot of strength. It's going to be real skinny, and it's going to be negative 4, so that means it's going to go this way to the right. Okay, it's going to go to the right a little bit. I don't know exactly how much, because remember, it doesn't really move exactly forward, and it goes down a little bit, and then it's going to go up 2, so up 2. So I can find the middle easily. So what I could do is, okay, let's scratch this off. Okay. The opposite of this makes it 4. Okay, and we divide that by double of that, which is divided by double of that, 10. So the middle will be, the axis of symmetry will be 4/10. We'll cut that in half. We get 2/5. 1/5 is 20 cents, so 2/5 is 40 cents. So it's going to be right here. That's okay. Watch this. See, it's right here. Boom, at the middle. And next, you're going to plug in 0.4 here, square it times 5, and then you're going to put 0.4 here times 4, and negative 4, and then you're going to add that, and then whatever that is, plus 2, and that'll give you your lowest point, which would be your vertex. Okay. All right. So it's up here. I'm going to zoom out a little bit. Press arrow. Okay. Next. So that's the vertex. Next, you can find your y-intercept. The y-intercept is 2, which is always c. So put that one. Okay. So see, I'm kind of doing it like if I was drawing it myself. Okay. Next, I can actually mirror y-intercept. So the mirror of that would probably be like right somewhere around here. Okay, I'm kind of eyeballing it. mirroring that. Looks like